Hello, welcome to the 11-4 notes on three-dimensional figures, and we'll be discussing types of solids, polyhedra versus not polyhedra. So that's what we are starting with. On the left, you will see examples of polyhedra, which is plural for a polyhedron, more than one polyhedron. On the right, you will see what's not a polyhedron. If you notice on the right, the reason it is not is that you do not have polygons because you have curved or it is rounded. And that is why it is not a polyhedron. On the left, you will have a polyhedron. Two different types of polyhedra, prisms and pyramids, are showing. Now, with the prism, you will see two bases. We'll talk about the one on the top and the one on the bottom. Those two bases are congruent and parallel. The sides are rectangles. Versus the pyramid, which only has one base, and your sides are not rectangles, they are triangles. So, what makes it a polyhedron? We have flat surfaces, which happen to be polygons, and we also have straight edges. No curves, nothing is rounded. Okay, so let's discuss the parts of our solids that we are discussing. Starting with coloring in the top and the bottom to show you the base so you can see a little bit better. So sometimes it helps if you shade in the base. And since I have two bases, I will shade in both. It helps see it clearly. Okay, the parts, starting with the base. So you have the top, here's the base, and remember it's congruent and parallel to the base on the bottom. Just as a reminder, they are congruent and parallel. We have vertices, and your vertices, that's plural for vertex, they are your corners or the points. We have edges, straight edges. Those edges are segments. And we have what's called a face. The faces are all flat surfaces, which of course are your polygons. And yes, the base is the face. So let me move over to the left a little more. If I want to name my polyhedron, so naming, oops, let's try that again. Naming, you're always going to name it by whatever the shape of the base is. So by the shape of the base. So since the base is a rectangle and it happens to be a prism because we have two congruent parallel bases, we call this a rectangular prism. That's how we name our figure. Okay, so let's try naming some of these. Again, it might be helpful to shade in the base. And I do have two of them. So the shape of the base is a pentagon, and since I have two congruent parallel bases, it is called a pentagonal prism. Don't be tricked with this one. You have to look for the two shapes that are congruent and parallel. That's the key. They have to be parallel. So this one's sitting on its side. The bases are triangles, so therefore it is a triangular prism. And then the last one it's a pyramid. The shape is a hexagon, the base, so I call it a hexagonal pyramid. Now, one important piece of information with pyramids, that point at the very top is called the vertex of the pyramid. Vertex of the pyramid. Okay, and that is naming the polyhedron. Now we have what's called a cross-section. The cross-section is, as you might have noticed with the pictures, the intersection of a plane through a solid. So it's like putting a piece of paper, slicing the paper through your figure. So here's my paper I slice through, and inside this is the figure. So what is that figure? That figure is a circle. So most of the times the shape will be similar or congruent to the base. This one would be similar to the base. Same within the next pyramid. If this is a square pyramid, the cross sections are going to be similar to the base, not congruent. Excuse me. So my cross sections are squares. The cross section in my triangular prism happens to be a triangle. Now look at the last figure. If I do a cross section horizontally, you will have a circle. But what if I do a cross section? Oh, right down the center, like this. Now, that's not a circle. So think about this. If you saw a can and you placed something down into the can, your cross section will be actually a rectangle, because you're going vertically. Okay, and that takes care of cross sections. Solid of a revolution. Okay, what does this all mean? If you look at the before and after picture, if you had a triangle on the stick and blew it really fast, it would go in a circular rotation, revolution, and it would appear to be a cone. So it would look like, oh, not like that. It would turn out looking similar to that. Okay, so you're going to be given a figure and you have to do a few things. First, you have to sketch the solid produced. So looking at the rectangle, if you were to spin it around and around and around, you know it's going to be going in a circular rotation. And then after we sketch it, we need to identify and describe. So there's 3 things you're going to be doing. First, let's sketch the figure. So it goes around in a circle. And you know my sketches are not very good, so that's not too bad. And I want to be specific, and I'm looking at my figure and it's showing that from the center, which would be where the stick is, to the end in the circle, that would be the radius, that is 5. The height of the figure is 10, and you can also put it on the inside, it's up to you. Okay, so that is sketching the figure. Now I have to identify and describe. So identify, saying it's a cylinder, and describing it. So it's a cylinder with, it's a basic description, a height of 10 units and a base radius of 5 units. So a basic, simple 1 sentence, I identify the figure, saying it's a cylinder, and then I describe with the height and the radius and what they are. And that is our solid of revolution. And that, my friends, my students, that's the end of that one. This is a very short section. Hopefully you will have the time to finish your homework and do some review. Okay? Have a great day.